Hello folks, this one is about thermal properties, heat and change in temperature. In this one we're going to find identify a metal using the thermal properties, heat exchange actually. So let's read it. 200 gram of an unknown metal is heated to 90 centigrade, then dropped into 50 gram of water at 20 centigrade. So we have an unknown metal. Let's visualize it. Its mass is 200 grams. Let's call this M1 actually. Divide by 1,000, it will be 0.2 kilogram. And it's heated to an initial temperature of 90.0 centigrade degree, and we drop this guy into water. I'm gonna call the mass of the water M2, so the second object is water here for us. 50 grams, which will be 0.05 kilogram. And its initial temperature, maybe call this T1 initial, T2 initial, is 20 centigrade degree, 20.0. Okay. And the water temperature will rise. When we drop this guy into here, let's actually, well, visualize that again in a different picture here. So we had initial situation like that. Now we drop our metal object into the water. M1 is here now, M2 is out there, and they reach a final temperature. They will reach a final temperature lower than 90, higher than 20. We know that the metal will give some heat to water. Water will heat up a little bit, temperature will increase, while metal's temperature will decrease. And the question says their final temperature becomes 27.7 centigrade degree. And that's it. That's their equilibrium, no more changes. Identify the metal. Heat capacity of water is 4,190 is given. So how can I identify the metal? Is that I can find the heat capacity of the metal. I will call the C1 and check the list we have. We'll call the C2 because we called water M2 here. And check the table to see which metal would that be. The idea here is that heat that the metal gives is equal to heat that the water takes, right? Metal gives some heat and water takes it, and we discussed this, that they will be equal to each other. One could be negative. Whoever is losing heat will have a negative heat calculation, change in heat, and whoever is gaining heat will have a positive heat change. Actually, we can go ahead and call this delta Q1, delta Q2 because they are changing heat. To calculate delta Q1, heat that the metal loses, we will use M1 C1 delta T1. Here delta T1 is the main idea. We'll get a negative value when we say T final minus T initial because final is lower, but we can take the absolute value of it. That works perfectly fine. And delta Q2 will be M2 C2 delta T2. And again, we'll take the absolute values. And we can solve for C1 using that. That's the idea. So we'll say change in heat for the first object is equal to change in heat for the second object. So delta Q1 is equal to delta Q2. M1 C1 delta T1 equals to M2 C2 delta T2. Whatever result you get for delta T, take it as positive absolute value, and it will work. and put in all the values. RM1 is 0.2 kilogram. We don't know C1. For delta T1, I take it as positive, or I can just go ahead and change the larger minus smaller. So I can change T final minus T initial to T initial minus T final. That's equivalent to taking the absolute value. I'll get a positive value. So I always turn it into a version of getting positive value. M2 is increasing, so for that I'll say T final minus T initial. Again, that's equivalent to taking the absolute value. And put in the values again. I'm going to solve for C1. So let's leave it alone. Divide each side by 0.2 kilogram, and this. M2 is 0.05 kilogram. C2 is 4,190 joule per kilogram Kelvin. I'll put here T final minus T initial for water, divided by 0.2 kilogram, and I'll put T initial minus T final for the metal. Actually a mistake here, I should have called these T1 initial, T1 final, T2 initial, T2 final to specify. And these are two. Final temperatures are the same, so we can just go ahead and call them the final 27.7. And initial temperature for, let's go ahead and put in all these values. Let me drop the units here so I'll have some more space. I put everything in appropriate units, SI units. I'm gonna get my C as joule per kilogram Kelvin. T final for water is 27.7 minus 20. Remember, if we are taking the difference, converting the Kelvin or not converting, doesn't matter, difference will be the same. So I'm not taking trouble to convert from centigrade to Kelvin. I'm using directly centigrade. You guys go ahead and do the same. Again, difference will not matter. I'm going to add 273 here, 273 there, and they will cancel anyways when I take the difference. If it's not the difference, it matters. Keep that in mind. Down here I have 0.2 and T final, T initial, I'm taking the larger number minus the smaller just to take the absolute value there. So it will be 90 initial degree minus 27.7. So once I put in all these and solve for my C1, which would be the heat capacity for my metal, I'm going to find 129.47. Joule per kilogram Kelvin. And if I check my table, I'll see that this thing is check that, but I forgot. I believe it was aluminum. Let's see if we have our tables here. These are LF. Do we have the C table here? Okay. 129 points, so 128. So it should be gold. 129.47 is closer to gold, so it should be gold. Okay. So we identify the metal as gold. Alright, let me go back to my question here. Gold. Okay.